One of the contexts where the nurse may be asked to complete some conversions is in the context of intake and output. From your pre-lecture video, when we are talking about intake, we are talking about all fluids. That may be broth or a liquid soup, such as tomato soup. That will be juice, drinks with or without caffeine, liquid meds, fluid to swallow pills, IV fluids, tube feedings, and things that are liquid at room or body temperatures, so things like ice, popsicles, jello or gelatin desserts. So when you're looking at a patient's tray and trying to take note of what is intake, you are not counting their solid foods. So sandwiches, meat, vegetables, fruits do not count. You're just counting up liquids. But you also need to be aware that you need to include their IV fluids and their meds. When we are talking about output, we are talking about everything that leaves the body in fluid form. So that could be urine, wound drainage, watery stool, and vomit. When you are looking at word problems, the key thing is that you're not going to include anything that is in grams, because grams is a measure of weight. You would only include things that would be in milliliters, because milliliters is volume, so those are the liquids. Sometimes you will be asked to calculate the hourly urine output, and this is when they are looking at the function of the kidneys. You would like that number to be between 30 and 50 milliliters per hour. The way that you do that is you add up the total urine per your shift and divide by the hours of your shift. So you're not looking at the amount of time that elapsed between times that they voided or urinated, but you are looking at for the total of your shift. So let's take a look at an example of putting these into practice. So for this problem, you are caring for a patient from 7 a.m. to 3 p.m. Intake and output were both being monitored. The patient had nothing orally for breakfast. At 10:20, the patient voided 150 milliliters. Voided is that word that we're going to see for when they urinated. For lunch, the patient had 120 milliliters of water and a slice of dry toast. The patient vomited 180 milliliters at 1300 hours, voided, so there's another urinated, 100 milliliters at 1330. At 1400 hours, the patient took 2 tablespoons of Jello and 1 2/3 glasses of apple juice with a 1 ounce package of crackers. While in your care, the patient had an IV running at 100 milliliters per hour. What is the patient's intake? So focusing on the question, I'm only concerned here about intake. So even though many output numbers were given, I'm going to ignore them. I'm going to go back through this, and at this point I'm going to circle things that were intake. So there was 120 milliliters of water. The slice of dry toast is solid, so that does not count. Then we see there are 2 tablespoons of Jello. Jello is liquid at room temperature, so that one does count. There is 1 2/3 glasses of apple juice. And the 1 ounce package of crackers does not count because crackers are solid. And then there is an IV. I'll notice that the question asked me for everything in milliliters, so I want to convert to milliliters as I go. So the first thing that we had on the patient's intake sheet would be water, and that was already given to us as 120 milliliters, no conversion needed. Second was the gelatin, so the Jello, and for that amount we have 2 tablespoons. So this is where I need to do a simple conversion. We are to memorize that 1 tablespoon is 15 mLs. And so I see that I set that up to multiply, and that would give me 30 mLs. Next, we have this 1 2/3 glasses. And these are always a challenge when there's fractions, and especially when there's fractions like 2/3 that do not have a nice decimal. So in order to work with the 1 2/3 glasses of juice, I'm going to do my work over here to the side. So 1 2/3 glasses. We're going to assume that this glass is a cup because we were not told otherwise, and that is always the case. If you are using a different size than a 1 cup, you will be told. So I'm going to put that 1 glass is 8 ounces, because we memorized 1 cup is 8 ounces. And then we also memorized that 1 ounce is 30 mLs. Now, you'll notice that my 1 2/3, even though it had a fraction in it, that 1 2/3 is all on the top because it only had 1 label. And dimensional analysis is completely based on the labels. So my label did not have a fraction, and so all of this is on the top or the numerator. Now, getting this 1 2/3 into my calculator can be a challenge. So the way that I do it is I'm going to type the fraction first. So I'm going to type 2 divided by 3, and that will give me the decimal, and it is a repeating decimal for the 2/3. Then I'm going to add the 1 to bring in the whole number. So I add plus 1. And so now my calculator is saying 1.666. There's a whole lot of sixes. At the end is a 7. So my calculator has on it the exact decimal for this fraction. So then I'm going to go and multiply straight across. So I'll hit times 8, and I'll hit times 30. And in doing that, I get an answer that is a whole number of 400 milliliters. Now, if I had rounded this decimal for the original 2/3 of a glass, then this would not have come out as exactly 400 milliliters. So it's very important that you're entering the fraction on your calculator so that you get the exact answer. The wonderful thing is with using this conversion of 30 milliliters to an ounce, 30 easily divides by 3, and so that's why we get rid of that repeating decimal. So in my log here, the juice comes out to be 400 milliliters. The last thing that I have in my log is the IV fluid, and we see that that is 100 milliliters per hour. So that does have a fraction in the labels, so milliliters on top, hours on the bottom. When I look at my shift, I worked from 7 to 3, and so you can count them up on your fingers or do the mental math. That is an 8-hour shift. So I'm going to multiply this IV times 8 hours to cancel the hours, and that will give me that they had a total of 800 milliliters of IV fluid. Now I'm ready to do the math and add up the fluids, the liquids that this person took in. So I have 120 plus 30 plus 400 plus 800, and I have a total of 1,350 milliliters of intake. And so that is my answer to this question. Key things to remember is to make sure that you're getting everything in milliliters. We use dimensional analysis to do that. Make sure you're only taking down the things that are intake and the things that are liquid. So let's take a look at the next problem. This is the exact same scenario, but this time we're asked for output. So because we read the problem before, I'm just going to scan through the problem and circle those things that are output. We talked about voided is that nice word for urinated. So we have them voiding, we have them vomiting, voiding again, and that is all the output we have for the entire shift. So thankfully, all of these are already in milliliters, so it is literally just a matter of going through and adding them together to get our total output. So 150 plus 180 plus 100 gives us a total output of 430 milliliters. And so we'll look at our next example. It is continued with the same scenario, so we won't reread it. And for this one, they're asking us our hourly urine output and labeled to be milliliters per hour. So I scan back through. We have at 10:20 they voided 150 milliliters, and then again at 13:30 they voided 100 milliliters. So my formula from my pre-lecture video is the total urine divided by the hours of the shift. And so what I want to do, add up my total urine there is 250, so that I did by mental math because 150 plus 100. The hours of the shift we had noted before when we were doing intake to be an 8-hour shift, so divide that by 8 hours. My labels there are milliliters over hours, which is exactly what they asked me for, so 250 divided by 8 on my calculator is 31.25 milliliters per hour. And so we would be reporting this back to the physician. We did note in our pre-lecture video that the normal kidney function would produce 30 to 50 milliliters per hour, so they are hitting that normal range, and it would be up to the physician to decide if that's good enough or to continue monitoring the situation. So those are examples of intake and output. Again, you will have some practice problems in your homework and some similar problems on your assessment.